Hello guys, welcome back to my channel. So this is actually the Addmath question. Okay, so it's about, if I'm not mistaken, is the derivative, or in the differentiation chapter, because it is related to stationary point. So without further ado, let's do this question. So we are given that the function y equals to 2x cubed minus 9x squared plus 12x minus 3, and we need to determine first is the coordinate of the stationary point. So stationary point is by definition, if you learn in the Addmath class, is basically what? dy over dx, right? We need to find dy over dx first. Dy over dx of this function, okay, is d over dx of 2x cubed minus 9x squared plus 12x minus 3. So we need to evaluate each term, the derivative with respect to x. Alright, so the derivative of 2x cubed with respect to x is basically, so this 3 move in front, so multiply with 2, so 2 times 3, then the x will be x to the power of 3 minus 1, so we minus 1 from the previous power, okay, minus, so this power 2 will be multiplied in front, so we have 2 times 9 times 2. Alright, 9 times 2, 9 times 2, okay, 9 times 2, this is 2 times 3, okay, and the x will be x to the power of 2 to the power of x to the power of 2 minus 1, okay, we need to subtract 1, plus, so this is power of 1, so 12 times 1 is 12, x to the power of 1 minus 1, which is 0, so this has no x, okay, so it is 0, okay, minus 0, okay, it's 0, so let's evaluate this. 2 times 3 is 6, x 3 minus 1 is 2, minus 9 times 2 is 18, okay, x 2 minus 1 is 1, so it is only x lah, plus 12, x to the power of 0, which is x to the power of 0 is 1, okay, so 12 times 1 is 12, okay, so the stationary point, okay, and because we are going to find the stationary point, so stationary point occurs, stationary point, I will write it here, point occurs at dy dx equals to 0. So previously I told you that the stationary point is basically dy dx, right? Basically it is not complete, okay, the statement is not complete. So stationary point is basically when dy dx equals to 0, okay. So to give you a brief view of stationary point, so it is like when you have a graph, okay, like this. For example, you have graph like this. So stationary point occurs when at here, at this line, okay. So at this line, dy dx is 0 because it is constant, okay, with respect to x, okay. So over here is constant because this is yx, this is x-axis, sorry, it is constant with respect to y, okay, this is y-axis. So the y value is basically unchanged along this pink line, okay. So dy dx is 0, so it is the gradient, okay, the gradient is 0, okay. Over here is gradient is unchanged or 0, okay, so it is 0, okay. It is also same goes like when you have graph like this, okay, quadratic graph. So the dy dx is over here, okay, over there. So this is dy dx equals to 0, which means that the gradient over there is 0, okay, the gradient is 0. So when you have something dy dx is 0, we know that that's the, we call the condition for the stationary point. Alright, So because we know that dy dx is 0, so we know that dy dx is this. We already find it to be this value, right? So we just set dy dx equals to 6x squared minus 18x plus 12 equals to 0. So we need to evaluate this. You can simplify it by dividing all by 6. Okay, so 6 divided by 6 is 1, which is x squared, minus 18 divided by 6 is 3x, 12 divided by 6 is 2, 0 divided by 6 is 0. Okay, so you just press the calculator. Okay, or maybe I don't have to use it because this is actually simple to evaluate. So this is actually equivalent to 0. Okay, oops, I cannot have that. So this is equivalent to 0. Okay, so we just have x, so x times x is x squared. So we have 2 and 1 over there. So we need to decide plus or minus. So it is minus and minus, right? So x squared minus x minus 2x, which is minus 3x, minus x times minus 1, sorry, minus 2 times minus 1 is plus 2. So this is true. Okay, our factorization. So x minus 2 is 0, or x minus 1 is 0. Okay, so x equals to 2 or x equals to 1. Okay, you just move the minus 2 to the right hand side and minus 1 to the right hand side also. Okay, so we have two conditions. So we take back our function. So this is y equals to 2x cubed. So let me write it here. Y equals to 2x cubed plus or minus 9x squared plus 12 minus 3 plus 12x minus 3. So we just substitute x equals to 2 into the equation. So y equals to, so insert 2 cube minus 9, 2 square plus 12, 2 minus 3. So just press your calculator, you don't have to be worried. Okay, so let me find my calculator first. So I got here is 1. Okay, and also subs x equals to 1, so we get y equals to 2, 1 cube minus 9, 1 square plus 12, 1 minus 3. So we'll in return get what? So this is 3. Okay, so this is 3. Okay, so we'll get, so I got 2. So the stationary point has 2. We got 2 stationary points. So stationary point, so I will write like that. Point is, we have 2 points, right? When x equals to 2 over here and y equals to 1, and when x equals to 1, y equals to 2. So it is interchanging. Okay, so this is our stationary point. Okay, question Roman 2, the nature of the stationary point. So this is very easy. What is the nature? So we need to find it is what I forgot the name. It is minimum stationary point or maximum. So that's easy. We just take the second derivative of the function just now. Okay, which is, so our function second derivative. Okay, the second derivative d square y dx square, which is, we just take the derivative of this, the derivative of this. Okay, so we just take the derivative of this once again. So it is, okay, let's take the derivative d over dx, okay, of the 6x square minus 18x plus, is it plus 12? Plus 12. So just take the derivative. So this is 6 times 2, right? So we just move in front the power. So 6 times 2 is 12. X 2 minus 1, which is to the power of 1. This is 18 plus 0. Okay, don't have to write plus 0, is okay. So let's substitute the point to 1 into our second derivative. So d square y dx square equals to, just subs in the value of x, okay, the x coordinate, 12, so x is 2 minus 18, so 12 times 2 is 24 minus 18 is 4, right? Oh, sorry, it's not 4, it's 6, right? Yeah, so 6 is less than 0, so it is, if the second derivative is greater than 0, so it is minimum, okay, minimum point, okay, point. And for, okay, we have two stationary point, right? So 2 1 and also 1 2. So for 1 2, d square y over dx square is, just substitute the x value, right? So 12 times 1 minus 18, so 12 times 1 minus 18 is 12 minus 18, which is minus what, 6, okay, so minus 6 is less than 0, so by definition, if the second derivative of the function less than 0, so it is maximum point. Okay, so this is the nature of the stationary points, both of them. Okay, so yeah, so it's very easy. So yeah, we got it right over here. Let me check. Yes, I'm correct. Yeah. Okay, thank you.